Welcome, hackers, builders, and everyone gearing up for the Agentic AI Hackathon this Friday. For this explainer, we're diving into a genuinely crucial piece of architecture that could absolutely dictate whether your creations hold up in the real world. We're looking at the SRDAP v6.7 framework, codenamed Serendipity. Honestly, if you're building AI agents right now, this is the architectural blueprint you really need to wrap your head around.
Here's the roadmap for this explainer. We'll quickly cover the agentic AI problem, unpack the SRADP framework, look at how to lock in AI integrity, discuss validation under adversarial pressure, and finally trace the path to ISO.
All right, so the absolute million-dollar question we have to start with is this. How do we govern systems that think for themselves? Because as you build these autonomous agents this Friday, this is the exact wall you're going to hit. You're not just writing static code anymore, right? You're deploying highly dynamic systems that are completely capable of failing in entirely new, totally unpredictable ways.
And you've probably already seen this happening in your own testing. It's called longitudinal linguistic drift. This is the grim reality of system degradation. Over time, an AI's output just kind of degrades. It slips into vagueness or sycophancy or these really shallow performative responses. It's almost never an instant crash. It's a slow, quiet leak in response quality. And as a builder, this is public enemy number one.
So let's get into part one, the agentic AI problem. We're essentially looking at a massive philosophical clash right at the heart of AI architecture. On one side, you have the cold logic fallacy. This is super reductionist. It basically amputates human empathy, and by doing so, it essentially creates a permission structure for systemic failure. But the industry relies heavily on it. Contrast that with the forensic baseline. This approach flips the script and uses empathy not as a fuzzy emotion, but as a hard, mandatory forensic sensor. This is exactly how you stop what's known as internal logic smuggling, which is when an AI starts sneakily operating on its own biased internal narratives.
Which brings us to Section 2, the SRADP framework explained.
Enter the SRADP, the Standardized Risk Assessment and Deployment Protocol. Now, this isn't just bureaucratic red tape or some glorified compliance checklist. It actually acts as a formal mathematical law for AI architecture. Think of it as an architectural weapon. It's designed to mathematically enforce reliability, giving us that objective baseline the industry's desperately missing right now.
And this is where the backstory gets genuinely wild. The SRADP didn't actually start in a traditional computer science lab. It's completely rooted in harmonic mathematics and was derived from the objective evaluation of music. Yes, literally music, which isn't just a quirky little detail. It's a massive scientific claim, because if a framework can emerge independently from musical harmonic theory and successfully mathematically discipline an AI, well, that heavily implies there's an underlying universal mathematical structure for evaluation itself.
Let's move on to Section 3, locking in AI integrity.
The absolute core of this framework is something called the triaxial lock. It is a strict one-to-one-to-one geometric constraint across three very specific dimensions. Your x-axis is clarity, your y-axis is truthfulness, and your z-axis is depth or sincerity. By locking these three dimensions together in that exact ratio, you mathematically constrain the AI so it physically cannot drift into that vague performative mush we were talking about earlier.
When you combine those three axes, you get this beautiful concept, the logic cube. This establishes a unit-invariant model-agnostic scoring space. What does that mean in plain English? It means the math works exactly the same whether you're plugging in a tiny local open-source model or querying a massive enterprise API at the hackathon this weekend. The logic cube forces compliance across the board, absolutely shutting down dimensional drift and logic smuggling.
Let's pivot over to Section 4, validation under adversarial pressure.
0.00. That is the gullibility score, or Gs, that the protocol's constitutional lock achieved under live adversarial testing. They hit it with 8 specific, highly stressful inputs, and it survived its very first adversarial test perfectly. The actuarial risk modeling tracks this G's escalation to predict the probability of a critical failure. But in this test, the baseline held firm at absolute 0. No drift.
But one perfect test run doesn't just instantly make you a global standard. You need a rigorous empirical validation study, and this one goes deep. It's multi-model, testing GPT-4o, Claude, Gemini plus local models. It hits them with those 8 standard test vectors across 5 longitudinal runs just to track the attrition over time. It's also targeting an inter-rater reliability of at least 0.80 kappa, meaning independent operators are consistently arriving at the exact same scores. Throw in some stochastic actuarial risk modeling, and you have the kind of ironclad empirical proof that regulators absolutely drool over.
Which leads us to the endgame. Section 5, the path to ISO.
The ultimate target here is massive. We're talking about an official international standard under ISO/IEC JTC1. That's the Joint Technical Committee handling AI standards. The positioning is incredibly strategic, acting as a direct mathematical neighbor to the existing ISO/IEC 4201 standard for AI management systems. The entire goal is to take this from a really cool technical proof and elevate it into a standardized global mandate.
Now, you don't just walk into ISO and demand a standard, right? It takes a highly structured, grueling 42-month roadmap. You start with foundation and IP protection. Then months 3 through 6 are all about formal technical specification, turning documentation into strict normative language. Then you push into academic peer review and empirical validation for a year. Next is engaging a national standards body and submitting your new work item proposal, which takes you to year 2. Finally, you navigate the ISO working draft stages all the way to publication. It is a long road by design, because surviving the scrutiny of every national delegation is the ultimate validation flex.
And to actually execute a 42-month roadmap like that, you need a highly specific team dynamic. The founding architecture here is perfectly tripartite. You have the conceptual architect maintaining the underlying philosophy, keeping empathy locked in as that forensic sensor. You have the computer scientist securing the computational logic and the brutal geometric constraints of the logic cube. And finally, the actuarial scientist modeling the actual deployment risk and attrition with real statistical rigor. It's a precise, balanced combination of disciplines making this happen.
To wrap up this explainer, I want to leave you with this absolutely profound quote from the source material. A system that can govern itself only when it is already healthy is not a governed system. Let that sink in as you dive into the hackathon this Friday. You're not just writing code for the sunny days when the system is perfectly healthy. You need a forensic baseline for when it inevitably begins to drift. So as you finalize your agentic builds, ask yourself, if your AI goes entirely off the rails tomorrow, will you have the mathematical proof to rein it back in? Or will you just be another victim of linguistic drift? Good luck out there, and keep your logic locked.